Hello, this is Danny Adams, math class once again. I'll be talking about quadratic equation. So, what's quadratic equation? A quadratic equation is a collection of terms usually involving one letter, an equal sign, and some numbers. The letter represents an unknown. When you solve an equation to find its value, you found the value. Quadratic equation again is harder to solve than linear equation because it's trickier to make x the subject of formula. Solve quadratic equation by factorizing, completing the square method, and quadratic formula. So I would say, what is a quadratic formula and what is it used for? It allows us to solve general quadratic questions, like like we can use it like quadratic equations, the like almighty formula as well to generate the almighty formula. You can use it to solve any quadratic equation question. So here's the almighty formula, here's the quadratic equation. So with this quadratic equation, we can use it to generate the almighty formula. That's when it gives us s equals to minus b plus or minus square root of b square minus 4ac over 2a plus or minus sign tell us when to perform the calculation, what is plus and what is minus. So hereby it gives us two answers, which is x the first answer and x minus the second answer, or x the second answer. So I would say solving a quadratic equation, it means finding the values for the variables that makes the equation true. You understand? It's just like we can apply quadratic also in a real life time, like in a real life term. Like examples are person throwing a ball, like calculative, like the motion of the ball, um, from the time and everything to know if it's a true event, and again moving on both screws, from the start point to the finish point. And also probability, quadratic equation talks about physics like motion and projectile. That has to do with something starting from something finishing. So I'll be dropping some examples on quadratic equation. Example one I'll be dropping is let's take this example. Example one should be um let's do this probability. X plus 3 raised power 2 equals to 13 equals to 9. X raised power 2 plus 6x plus 9 minus 13 equals to 9x. So we'll collect like terms. I believe everyone knows how to collect like terms. Then we'll move the positive side. Where there is x, there will be x. Where there is no x, there will be separate. So we'll get x raised power 2 plus 6x minus 9x plus 9 minus 13. Then x raised power 2 minus 3x, that is 6x minus 9x equals to 3x. 9 minus 13 is minus 4 equals to 0. So this x raised power 2 will remain. So that's the answer for the quadratic for this quadratic equation. We can name the x to be a, 3 is b, and 4 is c. So just taking the whole quadratic formula, the whole x, ax plus bx plus c equals to like 0. Okay, I would say what makes an equation quadratic. For me, I would say it's a wonder why the quadratic are called why the equation are called quadratic. When the root quad tends to mean 4, shouldn't this apply the fourth degree equation? Incidentally, they are called quadratic. The naming and second degree equation quadratic has to do with the roots of mathematics which lies in. Here's how it works. Okay, here's how it works. Imagine that a rectangle is 2 feet wider than its long. How is the area of that rectangle expressed given leaving the length of the rectangle in a coordinate x? Now the width must be x plus 2. So since the formula for the area of the rectangle is, then the area of the rectangle must must be um must be a equals to x, open bracket, x plus 2, close bracket, x equals to x raised to power 2 plus x. That's a quadratic equation. So they are called quadratic equation because they can model the area of quadrilaterals. This is also why the naming convention of raising something to the second power is squaring. And note, if there is no square term, that means the equation is not quadratic. As long as there is a square term, it is a quadratic equation. Even if there is a square term and no higher power, yes, the equation is still a quadratic equation. So I think that's all for today. Thank you.